Hi all, this video is about assignment 5, and in assignment 5 we will be implementing a class called complex. And for this class, when I say complex, we will be writing a class for representing complex numbers. And for this class we will be overloading 5 operators, which are addition, subtraction, multiplication, and then the cout and cin operators, which are known as stream insertion and stream extraction operators. So we'll be overloading these 5 members for this class. So far in our classes, we have seen how to overload addition, subtraction, and multiplication, stuff like that, which are binary, and both the operands are of the same class. But we are yet to cover what our stream insertion and stream extraction operators are and how to overload them when it comes to writing custom classes. We'll see that in tomorrow's class. And yeah, so majorly we'll be writing a class called complex, and this class will have two objects, or sorry, two members, which are real and imaginary. IMG stands for imaginary. And just to show the assignment files, so when you download the zip file, you'll be finding complex.c++, which will contain all the functions, member function definitions for the class. And you will be writing the complete part of this. And coming to complex.h, there is not much to write in this part. The definition of the class is already provided for you. Note that there are two friend functions for this class, which are to overload the operators, stream insertion and stream extraction. And then this class will have two constructors. One is the default constructor and the other is parameterized constructor. And then we have three more functions that are overloaded for writing operators like addition, subtraction, and multiplication. And the idea of this assignment is that, say, if you are giving two complex numbers, we will be doing their addition, subtraction, and multiplication. And so firstly, you'll be asking the user to enter complex number 1. They will give the real and imaginary part, and then the user will be asked to enter another complex number, which will have real and complex parts of it, sorry, real and imaginary parts to it. And then the task is to add these two together, and what would be the result? Subtract them, what would be the result? Multiply them, what would be the result? And eventually, you will be using stream uh, insertion part to display these three lines. And then you will be overloading, or yeah, operator overloading for stream extraction for accepting real and complex parts for a given complex number. This is what we will be pretty much doing for in this assignment. So let's see how to achieve this. So yeah, just some background. So complex numbers are something that we write in this format. For example, 3 plus 2i. So anything that's before plus, this is what we call as real part. And anything that goes with I, this is what we call as imaginary part. So imaginary. My bad. It took me a second. This is the imaginary part. And in short, we are calling it as IMG. So now given these two complex numbers, given this complex number, first, and then let's say there's one more complex number, 2 plus 4i. So given these two complex numbers, we want to do addition and subtraction and multiplication and stuff like that. So all through the handout or the PDF, I have provided the formula for computing the addition, subtraction, and multiplication. So let's say if you have the addition function, if C1 is a complex number with A plus BI and C2 is a complex number with C plus DI, you will be adding them in this format. So both the, let's say, have to add these. So if I want to add these two complex numbers, number 1, and this one is the second complex number. So what I will be doing is I'll be adding the real parts, which is 5, and then the imaginary parts, which is 6. So this is kind of straightforward. Similarly, subtraction is also straightforward. You'll take off the real part of second number from the first one. You'll take off the imaginary part of second number from the first one. So those two are straightforward. There's only one catch, which is the way we do multiplication between two complex numbers. So I have given the formula clearly here, like how would we compute the real part when it comes to multiplication, and how would we compute the imaginary part when it comes to multiplication of two complex numbers. So please follow these guidelines, and you will be able to implement these functions perfectly all right. And talking about the complex.h class, let's see what functions do we have. So again, in complex.h, the complete class definition is provided for you. You don't really need to change anything. So class complex, and there are two friend functions here. I'll come to them, and we'll see in tomorrow's class as well, or the class on Monday as well, like how to write these friend functions with the rectangle class example. And we have two private variables which are of double type, and one is called as real and the other is called as imaginary, or IMG in short. So these are the two private variables. And then there are other public member functions. We do have two constructors. One is default and the other is parameterized. So both of them share the same name. And then here we have the three operators that we'll be talking in this video. So the first operator is operator plus. So I'm writing these functions as members of the class. When operator is member of a class, operator overloaded function is member of a class, we only need to pass one parameter because we can invoke the function with the other object. So now I'm going to write a function called operator. Remember, all the operator overloading functions start with the keyword operator, followed by whichever the operator that we want to overload. I want to change the definition of addition when two complex numbers are given to this function. So now, when I'm adding two complex numbers, in turn, I got another complex number. So that means if you're adding two complex numbers, the result is going to be a complex number. So this function should give a complex number back to the original or whoever is calling the addition operator on complex numbers. So it will return a complex number. This is the name of the function. And remember, we discussed a lot in class. If you are writing operator overloading function as a member of class, then we can only pass a single parameter. We'll see this part again. So I'm calling, you can call it as C2 just for the sake of convenience, or I have called it as other complex in the assignment. So it's up to you, whatever it is convenient for you, please feel free to change it around. So this is operator plus. Similarly, when we are subtracting two operators, when we are subtracting two complex numbers, we'll get back a complex number back. And again, if you're overloading a function and if it's a member of a class, you can simply pass one parameter, complex. And the third one is operator multiplication, complex, C2. Now, remember, one of the major things that we have to do when it comes to operator overloading is to define the logic on what should happen when you are overloading two or when you are overloading an operator. So all these logics of defining what a function should do should be given in complex.cpp. So take care of the default constructor, parameterized constructor. I'm only talking about these three functions within the scope of this video. So we know that this is returning a complex number and both the files are different. Observe this clearly. When you are defining a member function of a class, but not within the class definition, then you should always refer to it with the class name. So the class name is complex. This is how I'm referring to it. And this is the operator plus, and this function receives a parameter of type complex. And let's call it C2. go ahead and define the function body. Now let me talk about main here. This part right here, let's assume that it represents main.cpp. So within main, what's happening is I'm declaring one complex number. So the data type complex and C1. Okay. And I'll be, let's say, so for example, I'll talk about the C in C out part in a while, but let's say C1 is 2 plus 3i. Let us assume this part. Okay. And now I've declared one more complex number. Let's call it C2. And let's assume C2 is 4 plus 5i. Okay, we have two numbers C1 plus C2. Our task is to add C1 plus C2. When you are adding two numbers, two complex numbers, automatically, the compiler will treat it as call the function operator plus using this object. So operator, and then it will use C2 as the parameter. So this C2, whatever we are passing, will be received here. So this is getting called as parameter. And this one, C1, is accessible within the scope of this function because you are invoking a member function on another member. So all we can simply do here is that uh, when you are adding two complex numbers, you will get one more complex number back. So all you have to do is simply create another object and you can call it as C3. Okay. And now the real and imaginary parts of C3. So the real part of C1, the real part of C2 should be added. So 2 plus 3i and 4 plus 5i. So the real parts should be added together, which is 6. So how can I access real part of C1? All I have to do is C1 dot real, and the real part of C2, all I have to do is C2 dot real. So this is serving as first, let me write it here again. So complex, I should create a complex number and I'm calling it as C3. Add both the real parts, C1 real plus C2 real, comma. So this is like calling parameterized constructor. I'm going to call this constructor, and for this constructor, I'm passing two arguments. The first argument is the real part, and the second argument is going to be c1 dot imaginary plus c2 dot imaginary. In this way, we are creating a new complex number based upon the real parts of first two complex numbers and the imaginary parts of the second one. And I just forgot, you won't be able to access C1. You should be, but you can directly access whoever is whoever is calling the function. You can directly access them. So always remember this point. My bad, I just forgot it. Yeah, just a second. Yeah. So this is going to be simply IMG. So whatever the real part of first number, you can directly access it. C2, you can access it through the parameter. In this way, you will be writing the functions for operator subtraction and also operator multiplication. So create new complex numbers and return them back. That's pretty much how we'll be doing. And now, talking about the stream insertion and stream extraction operators. So for this part, Mondays class is also important. So the way C++ creates cout scene is that there is a base class called as iOS. Okay, there is a base class, and this base class was inherited by two other classes. One is iStream class, and then there is another class called as OStream. Okay, these two classes are very important. Now, what what is defined in these classes was um, there is a class that was defined for all the things that should happen when you do C in, and then there is a class that was defined to take care what should happen when you do cout. So C in cout are not the class names, but they are the objects that we are using directly. But all the logic to take care of getting the input from the user, writing the output to a terminal was taken care in these classes. Okay, and my bad. Let me write it properly. So the class is ostream, and the object that we use is cout. And here also the class is istream, and the object that we use is scene. So given these two objects, we are directly able to access them. And now our idea is that whenever we do cin followed by a complex number, we want to accept, again remember, this means this means complex numbers doesn't directly work with cin. So we will be writing a function called operator, and then the stream operator. So you'll be writing a function inside this class. This is going to be a friend function. Now this is the function name. And when we do this, the compiler is automatically going to consider it as operator cin comma c1. Now notice that I'm passing to both of them as parameters for this function. That means remember the logic that we discussed. If this is the operator and we are overloading this for a class called complex. Okay. So class name is complex, and look at the left hand side. If the left hand side object is not of this class, then we should be overloading this as a friend function. So this is must ensured. Similarly for cout. So the way we will be writing this function is, this is a friend function. This is the just the prototype of the function, and cin is of type istream. I will return back istream object, and I will tell you why we should return this item back. This is the return type. And now I'll tell why we return this in class on Monday. And whatever the function name is operator, we are overloading the stream insertion. So, and now this takes two objects. First object is of type istream. So always remember this. Scene is the object, istream is the class. So here is the object, class istream, and the second parameter is going to be of complex type. So this is pretty much the function prototype. Arguments, this should go here. Arguments, function name, or parameters, friend function. So and sometimes what we do is, since we are passing the address of a variable, so no one cannot change the original data. So with that intention in mind, we will make it as a constant argument. Arguments or parameters, and these are formal. So this is the function prototype. Now coming to the function definition, when you are defining this function, you don't write a friend keyword. So go ahead and write the return type of the function. The name of the function is operator, and this function accepts two arguments. One is istream type, class name, and you can call it C, or I'm calling it simply as in. And the second one, remember, if a function is not changing the value of an object, and if you don't want, you can call it as constant, and it's a complex object and passed by reference, and you can call it C. Now, again, I'm emphasizing on this point. The writing syntax part of a function, you can find it anyhow. But what should happen when this function gets invoked? Whenever someone is doing cin on a complex number, is what we should write. That's the most important thing in operator overloading. So what should happen is that this is like our regular scene statement, but the only condition or the change is that I'm calling C in as in within the scope of this function. So I can also do something like this. I can write a C out and say enter uh, real part. Okay. And then endl. And I can simply remember now I'm calling it as in. So I can simply do something like receive the input. This is the complex number into the real part. And I can do one more C out and say enter imaginary part and simply receive it imaginary part. So in this way, I can receive this. And last point, this is the return type of the function. So what I should do is I should simply return in object back. And the reason I'm explaining this superficially in this part, the reason why we return this back is that to allow C++ to do something like this. C in C1, read the first complex number, followed by read the second complex number. So this is what we call as chaining in terms of programming. And to allow this chaining, some of the return types, we return it back. So the way this chaining works is it goes from left to right. So when you do C in C1, the compiler thinks of it as calling this function called as operator. Call this function operator on C in comma C1. Okay, so that's how it thinks. And then when you do C2, so this function will return the scene object back, right? So again, the compiler will call the operator stream insertion function using the received scene variable and with C2 as the other parameter. So to allow this chaining process, sometimes we return back the stream operators, and also in some cases like unary increment, unary decrement, we will follow a similar trend. So that's pretty much why or how or why we return back the stream operator. It is to facilitate chaining. Similarly, I'm not talking about cout, so your part is to write cout in the similar fashion. And eventually, um, the last talk assignment is that I provided you main.cpp, but not completely implemented. So you should be reading in the data. I've provided like have to read in the first complex number. Your part is to read the second complex number. I've provided have to add two complex numbers and have to print them. And your part is going to be have to subtract them, have to multiply them, and have to do the C out of subtraction and multiplication. So that's this have an equals is not